we're going to solve a system of equations by substitution. The first set of equations that we're going to try, I'm going to go ahead and number them 1 and 2. And these are really nice because the goal of solving a system of equations by substitution is to first get one of the two equations, at least one of them anyway, set up so that you have isolated one of the two variables. Now this is really nice because in equation number 1, the y variable is already isolated, so I don't have to do any work. I've put a box around 6x minus 11, and that is because that's the expression that is the same as or equal to y equals 6x minus 11. That means that I can replace the y in the second equation right here with that expression, since they're the same thing. So what I'm going to do is I'm going to go ahead and rewrite the second equation exactly the same except for the y. I'm going to stick in there, or substitute is a better word, 6x minus 11 for the y. Okay, and now I've got that equal to 7. What I'm going to go ahead and do is simplify that using the distributive property to start with, and I'm going to end up with negative 2x minus, now I've got 3 times 6x, which is 18x, and then I've got the minus 3 times minus 11. That's going to give me a positive 33. Okay, so it's really negative 3 times negative 11, and that all equals 7. Okay, the right hand has not changed at all. So now I'm going to do a little simplifying of like terms. And I'm going to combine the negative 2x and the negative 18x, and I'll have negative 20x plus 33 equals 7. And I'll go ahead and solve that by taking 33 away from both sides. Oh, I forgot. Actually, I forgot a little thing off the very original equation. It's supposed to have a negative in front of the 7. Okay, that's going to carry through. All right. Okay, first, the positive 33 and negative 33 equals 0. So I don't even need to rewrite those. I'm going to bring down my negative 20x, bring down my equal sign, and then I'm going to add my negative 7 and negative 33 together. All right. Now I've got negative 20x equals negative 40. If I go ahead and divide both sides by the coefficient of the x, the negative 20, that's going to end up canceling those out. And I'll end up with x is equal to positive 2. Okay, unfortunately, I'm only half the way done. I still need to know what y is. The way to find out is for me to take the 2 and replace the x in one of the two original equations. These are the ones I'm talking about, these two. Now I'm going to pick the first one because it looks easier. Y equals 6x minus 11. And what I'm going to do is I'm going to replace that x with this 2. All right? As you can see right there, I'm going to rewrite the rest of it. Y equals 6 times 2 minus 11, or y equals 6 times 2 is 12 minus 11, or y equals 1. At least that's what I think. I believe the answer is 2, comma 1. That's my x, the 1 is my y. What I need to do now to know for sure is to replace the x and y in both of the equations. So let me start with equation number 1. My y is going to become a 1. Instead of 6x, I'm going to have 6 times 2 minus 11. So 1 is equal to 12 minus 11, or 1 is equal to 1. Now that looks good. In the second equation, I'm going to have negative 2, x is going to become negative 2 times 2, and it's minus 3y, so it's going to become minus 3 times 1 equals negative 7. Let me do a little simplifying here. Negative 4 minus 3 equals negative 7, and that also is a true statement. Okay, the whole idea of finding a solution is that you are finding a single coordinate point like this that works in both of the equations, not just one of them. And this right here is the only point that it appears to work in both equations. Now I'm going to try another example. Oh, I'm going to write answer right by this to make sure it's very obvious that this is the answer right there. Okay, now on to the next equation. This is a little more challenging because I've got two equations, but a variable is not isolated in either one of these two equations. Looking at these, I'm going to go ahead and number them 1 and 2. I believe that it will be easier to isolate a variable in the second equation because the x does not have a coefficient in front of it. Therefore, it would be pretty easy to move that equation around. I'm going to go ahead and do that by adding 2y to both sides, and that way my x will become isolated. That's right, I'm going to have x, this goes away, becomes 0, equals 11 plus 2y. Well, I'm going to write the 2y first, plus 11. So now I've got a second equation where my x variable is isolated, and the expression that represents x is 2y plus 11. In the very first equation, I'm going to replace the x with this expression. So it's going to become negative 7 times 2y plus 11 minus 2y equals negative 13. And again, this is all from this very first equation. Everything's the same except for the expression 2y plus 11, which I use to replace the x. All right, now for a little simplifying. Distributed property is going to make negative 7 times 2y become negative 14y. And negative 7 times 11 is negative 77 minus 2y equals negative 13. I'm going to combine my two like terms. That's this one and this one because they both have y in them. And I'm going to have negative 14 plus negative 2 is negative 16y minus 77 equals negative 13. I'm going to go ahead and add 77 onto both sides. And I'm going to get negative 16y, that's 0, equals, well, whatever negative 13 plus 77 is. Looks like 64. Okay. Now I'm going to rewrite this because I'm running out of room. I'm going to write it way up here. Negative 16y equals 64. All I need to do now is divide both sides by the coefficient of the variable I'm trying to isolate. That would be the y. And on this side, that's going to cancel itself out. And I'll have y equals 64 divided by negative 16. Well, 64 divided by 16 is 4. And I've got a positive and a negative, so it's going to be negative 4. So I believe my answer is negative 4, comma, something. I don't know what that is. All right? So the way I find out is that I'm going to replace the y value. Oh, wait a minute, that was a y. I put that in the wrong spot. Oops. Got to fix that. Here we go. Okay, I believe the y is a negative 4. So I'm going to replace the y in one of the two equations with negative 4. And I choose the second equation because it's just shorter and looks like it's going to be a little easier. They're identical except for that the first one's got a coefficient in front of the x. So it's going to become x minus 2 times negative 4 equals 11. So that's basically the entire second equation with the y replaced with a negative 4. Okay, so now I've got y equals, x plus 2 times negative 4, 8, 11, and take away 8 from both sides. I have got x equals 3. Okay, so I believe my answer is 3 comma negative 4. What I need to do is try that set of values in both of the original equations. Okay, so my first one will become negative 7 times 3 minus 2 times negative 4 equals negative 13. And that's going to give me negative 21 plus 8 equals negative 13. Well, that's true. Negative 13 does equal negative 13. So that's a check mark. I'm running out of room, so I'm going to check the other one. That would be the second one up here. I'll find a little room. I guess I'll use this. I'm going to make this little box right here to do it. Okay. Instead of x minus 2y, I'm going to have 3 minus 2 times negative 4 equals 11. All right. That becomes 3 plus 8 equals 11, which is 11. 11 equals 11, and that's a check mark because that's also true. I am done with this example. I'm going to move on to the next one. Oh, there is no next one. Thank you for watching today.